the computer. Yes, of course, all of that we were been learning all these days was about computer, but today we are going to go little deep into the CPU, and then we are going to find out what are the real components of CPU, and then we will be learning about the CPU. Alright, so now let me show you to the slide. We have introduction to computers. If you can remember, when we were talking about introduction to computers, yes, of course, we were been learning about how many types of computers are there and what are the categories those are bifurcated into computers, and then we have so many and then so many. Alright, so today we are going to learn about, yes, the same fundamentals of computers, but into the CPU. Alright, so now let me tell you what is CPU. Yes, it is Central Processing Unit. As I have said you, it is the brain of the computer, isn't it? So now, when I say it is the brain of the computer, obviously every function will happen through the CPU. When I say every function, that means the CPU is a capable device which takes the advice, calculates into the binary language and releases in the language which we understand. So this is what the function and the job of the CPU. So when I say CPU, you always have to remember CPU is just not the brain of the system, but it is also the mother of the computer. So always remember that when I say the mother, it has the entire operational controls from it. When I say operational controls, yes, storage devices, operating system in the hard drive, and every component that passes electricity is from CPU. So when I say CPU is not there in the computer, that means computer is also not there, right? So CPU is the most important thing in our 5th generation that you have to remember when we go into the deep of the CPU. So now let me show you the CPU and its components, alright? So if you can see the slide here, we have Central Processing Unit, CPU. CPU is the brain of the computer. It is a portion of the computer that carries out the instructions of the computer program to perform the basic arithmetical, logical, and input and output operations of the system. It consists of a silicon chip which houses millions of transistors. And now, what is the meaning of this? When I say this, you just have to remember that CPU is one of the main components that passes the entire information to the computer. If you connect your computer to the internet, the first thing that you type in Google, for example, when you go to Internet Explorer and type Google, what does this mean? Google, isn't it? So when you type Google, the next second itself, a page of the Google will display on your computer, on your monitor in fact. So what is or how is this happening? This is just happening through the CPU, because the brain of the computer is CPU. So the brain will basically calculate what exactly we want, and then what it do is it just get that from the Google or from the Internet Explorer, and that gives you the display on your monitor. So always remember that any function or any operation that you do in the monitor through the keyboard or mouse, this indirectly or directly goes to computer, that is CPU, the brain of the computer, that is CPU, and it functions over there, calculates, understands it, and then releases the output. Yes, if you can see the slide once again, if I have to show you the slide, yes, I'll read you the first point once again. CPU is the brain of the computer, as I have said you right now. It is a portion of the computer that carries out the instructions of the computer program to perform the basic arithmetical, logical, and input and output operations of the system. As I have said you, yes, apart saying that it is the brain of the computer, the second thing that I just want to tell you is it is a part of the computer which takes the instructions. Obviously, when you give an instruction to the computer or when you give an input to the computer, where do you think that it will go? Obviously, it will go to the CPU. And in the CPU there is something called as motherboard, and it tries to take all the information. So any instructions that you give to the computer, the first thing that happens to the computer is it sends the instructions to the CPU, and then the CPU revert back on the information what you require. Yes. And now let me take you with the third point in the same first point. Now, can you just see the slide here? Yes. To perform the basic arithmetic, logical and input and output operations of the system. Yes. And now, when I have said you instructions, what kind of instructions are this? Yes, I was talking about the brain, and then there is this thing called instructions which has been given to the computer. But do you think, what kind of information is this? It can't happen like you just give anything and the instructions will take. No, isn't it? So the machine have few particular things especially that it calculates as an information. So when I say few particular things, what are those few particular things? Yes, those are arithmetical, logical and input and output information. So these are the most important thing that you have to remember in the first point. Yes. Can I take you with the second point? Yes. It consists of a silicon chip which houses millions of transistors. People, in the right side you have the image of CPU. Yes. Of course, when I say CPU, we have a lot of wiring into it, isn't it? And if you can see straight away, you can see a fan. And then you have the motherboard which I was talking. There is a silicon chip in that motherboard where it houses millions of transistors. You can see there are lot many binary things that are kept in the motherboard, and all these informations will be gathered by this silicon chip. So always remember that this is the basic components of the CPU, and I have just given you the only meaning of the CPU. Now let me take you with the deeper side of what is a CPU, because of course when somebody asks you, or when you are there, if something happens to your CPU, what is that you're going to do when you don't know anything about the CPU? Or when you go for an interview, there will be so many questions that utter saying, what do you know about CPU? Or can you just tell me what are the three main components of the CPU? Or there can be questions where indirectly or directly they might put up questions into the deep of CPU, how the CPU functions, or what are the main functional components of CPU. All these are some of the important questions that come under your life. So please ever and never forget these important information that I am telling you. Now let me go through you with the second slide. Yes, here I can make you display the main functions, or what is exactly the CPU. Guys, when I say about the CPU, you can just see 4 equipments on the diagram. Yes, first you have the main memory, which indirectly or directly giving the information to arithmetic logical unit, that is CA, and then it goes to program control unit, as well it goes to IO equipment, and then it is a vice versa. It comes back, the information comes back to arithmetic logical unit, and it exchanges with program control unit, and then give it back to main memory. So that's how the entire operation of the CPU will happen. I want each and everybody to have a basic diagram of central processing unit. This diagram will help you in understanding the main function of the CPU. I'll repeat it once again. Yes, the function of the CPU happens with the main memory and passes that to arithmetic logic unit, and then passes sequentially to IO equipment and program control unit. And then we have I/O equipment, which gives back the information to arithmetic logic unit. At the same time, program control unit, which is a vice versa with the main memory, give and exchange the information, and then everything is basically happening with the main memory of the CPU. So this is the basic diagram that you have to remember, especially when it happens when we are talking about the CPU. Okay. So now, let me tell you what are these things. What is arithmetic logic unit? What is main memory? What is I/O equipment? What is program control unit? Before I say all this, I just want you to remember the entire information of the CPU that I am telling you, because people, the only thing that you have to remember is CPU is something which is very different from other components we are talking about. Because yes, we were been talking about so many equipments and so many things that exist in the fundamentals of computers, but yes, when I come to CPU, it is more of in deep and tough to remember some things, because yes, CPU is something which is totally a different kind of confused structure, which indirectly or directly you might not remember, because there is a lot to view in the CPU. All right. So now let me take you with the next slide. Yes, if you can see here, central processing unit. When I say central processing unit, yes, the three main components are arithmetic logic unit, control unit, and the registers. So ALU, when I say ALU, you have accumulator, logic circuit, and the registers. You have a separate part of control unit, and you have registers. So please remember this. I'll read it once again for you. The three main components are arithmetic logic unit, control unit, registers. And if you can see the diagram here, we have control unit, which is giving the information to memory unit directly, or it gives the information to logic circuit and then exchange with accumulator, and then it exchanges with register. Yes, and the registers and accumulator indirectly or directly exchange the data with memory unit. So this is the basic diagram of the CPU. Yes. So I think I am very clear on what I exactly have said, right? So now when I say CPU, the CPU is something which you should always remember, and in this brain of the CPU, we have three main important things. And what are those three main important things? When I say the three main important things, the first one is arithmetic logic unit, control unit, registers. Yes. So when I say these three things which are important in CPU, always remember the only three components of CPU, because these three parts are something which runs the CPU, because without these three things you can never ever forget, or you can never ever control anything in the computer. And to give a basic example, yes, we have our brain, isn't it? So when I say we have a brain, how does the information get gathered into the brain? Through our eyes, through our ears, and through what we talk. So when we do all these three, the information get gathers into our brain and reflect back to the mouth so that when we talk, people understand, isn't it? So it is a vice versa thing. So always remember that. So now let me take you with the slide once again. If you can see the slide, we have arithmetic logic unit, which we can say it is ALU, the unit that performs arithmetic and logic operations such as addition, subtraction, shifting operations and logic instructions. You can see the diagram here. In the diagram, you have 4-bit ALU, where there are two bifurcations, one is A and one is B input lines. A3, A2, A1, AO are the segments bifurcated in input lines of A, and we have B input lines where B3, B2, B1, BO are the segment lines in the arithmetic and logical unit of the chip. And we have something called as Kranth. And then we have F3, F2, F1, FO as outputs. S2, S1, S2, CIN are one of the basic information that gives to the ALU. So the brown chip which you can see under is something which I am talking all about from all the time. So these are the basic deep structure of ALU. Now I will read the sentences for ALU. The unit that performs arithmetic and logic operations such as addition, subtraction, shifting operations and logic instructions. They are designed to perform integer calculations. Hence, ALUs also handle multiplications. It consists of a logic, circuit and an accumulator. ALUs do not perform divisions, as a result may be a fraction which is known as floating point. Hence, divisions are handled by the FPU, which is called as floating point unit. Alright, now when I say about ALU and when I was explaining about ALU, the first thing that I have said you is all about the point. Yes, the point of information. And what is this information? When I say about the information, all that you just have to remember is this information that is being calculated. The calculated part is actually done by ALU. And when I say about ALU and its calculation, what does we have in the calculations? Of course, when you remember the mathematics in your previous age, of course, when I say calculations, you have additions, subtractions, and you have the basic components of calculation like board mass, like brackets, multiplication and etc. and etc. The same thing in the first point I am talking about in the ALUs. All the calculations of binary language happens through ALU, and the ALU means arithmetic logic unit. Alright. Now I will go with the second point. They are designed to perform integer calculations, hence ALUs also handle multiplications. As I have said you, yes, apart from additions, subtractions and everything, they also do multiplications, because we don't know what information are we looking at for? Because we just type something, we just give an input to the computer, and we have several examples for the information what you are looking for on your monitor. And how does this happen? It just happens with the help of ALU in the CPU. So this is what you always have to remember when I'm talking about the ALU in the CPU. All right. So let us go with the next point. It consists of a logic circuit and an accumulator. What is a logic circuit and an accumulator? Yes, when I say about the accumulator and circuit, these are the two main things that you can see on the diagram, which in fact process this calculation back to the monitor, or if you can see, we have CPU and its components, which vice versa the calculations inside the circuit board. Now let me take you with the next point. ALUs do not perform divisions, as a result may be a fraction, which is known as the floating point. Now when I say this, yes, I was talking about addition, subtraction and shifting operations. Yes, but I also have said you multiplications. But did I say division? No, isn't it? So yes, it is true. It never divides. ALUs can never divide or can never do division points, because they are known as floating point. I mean, at one particular point, yes, they literally cannot calculate the division things, that instructions which you give to the CPU, and indirectly or directly they will be known as floating unit. So that is what I have mentioned in the last point, if you can see the slide once again. Hence divisions are handled by the FPU, that is floating point unit. Yes, when I speak about the CPU, there is a separate division in arithmetic logic unit, where apart from CPU we have FPU which does all this. It is not a particular device or something which is separately fit in the computer. In the arithmetic logic unit itself, there is a basic component or a chip which does the floating point unit, that is simply called divisions. Right. So these are being actually handled, the divisions, especially the divisions are basically handled by the floating point unit, which helps you in giving the instructions every time for your computer. So always remember, when you give the instructions, there is a lot of machinery programming which is happening into your CPU, and we never knew about it. But at the end, the only thing that happens to us is satisfaction of getting your answer. But inside there is all this process which is happening in arithmetic logic unit. So that is why it is called as arithmetic, a very big calculator. All right. So now let me take you with the next slide. So here we have the binary code diagram of arithmetic logic unit, ALU, where the first system starts with A 7:0, and then we have B 7:0. Let us come with the A 7:0 diagram, which have the arithmetic unit, logic unit and shift unit, and then it results to the output. The same with the B 7:0, but if you can see down, we have the output divided as the 2-bit and the 4-bit. So this is the information basic diagram of arithmetic logic unit. Until and unless you dismantle the CPU and work on the monitor or on the monitor perspectives of the CPU or the arithmetic logic unit or the chip, then only you can understand what is all this. Because when I give you the information, it is just to remember, not to trial, right? So yes, there will be a particular situation where you will be working on your computer, especially on your CPU. When you remove your CPU parts and work on them, then you will understand what is this input, what is the output, what is the A ratio, what is the B ratio, because this is the internal part of the arithmetic reasoning where we really can't even see this, because this is an information diagram, how actually the information goes through, right. So now let me take you with the next slide. We have the same, a simple diagram of ALU and version memory. All right. So when I say memory, when the memory is going with the control unit, as I have said you, at the end, arithmetic logic unit, especially the accumulator, takes the input and gives the output. But from where does this happening? It happens through the control unit. And when I say control unit, yes, it gives a vice versa information with memory. Of course, ALU also divides its memory, and then at the end, all these together, the initial memory control unit and ALU with the help of accumulator will take the input and gives the output. But when they are doing the input and output, control unit and memory are something which are used to have an understanding about the entire system. All right. Now, so it is very easy to remember about ALU, because ALU is one of the best things that performs in the computer, because without ALU nothing will happen in the computer. So always remember that ALU is one of the most important things that exist in the CPU. All right. So now let me take you with the next slide. Control unit. When I say about the control unit is basically the circuitry inside the CPU that controls all the operations and directs them. It directs the computer by sending the control signals. Next, the functions of the control unit depends on the type of CPU. It handles all the processor control signals and directs the input and output flow. It regulates the timing of the processor. So if you can see here the diagram, instruction register, control unit, you have flags, clock, etc. getting into the control unit. That exist out of control unit is control signals within the CPU, and they have an incoming there, that is control signals from control bus, and it reflects back the control signals to control bus. Yes, I'll read the first point once again. The control unit is basically the circuitry inside the CPU that controls all the operations and directs them. It directs the computer by sending the control signals. All right. When I say this point, the most important things that you have to remember is, let me give you an example. All right. So why do we put water into the bottle? Yes, this bottle is a control unit. For example, imagine we have a bottle and we are putting some water into the bottle. Why? Because later we can have the water from the bottle, isn't it? So this is also the same. Control unit is a basic location device. I mean, it is located in the CPU that it takes and gives the control. Yeah, control unit itself have the answer in it. A unit in the CPU which controls all the signals or all the instructions and revert back by sending the same controls to the devices inside the CPU is called a control unit. It's a very easy thing to remember. Control unit is nothing but a unit in the computer which controls all the informations that received by the inputs and which revert back by giving the controls to the internal parts of the CPU is called a control unit. So this is a basic example that you can give to anybody when they ask you what is a control unit in the CPU. Alright. So now let me take you with the second point of control unit. The functions of the control unit depends on the type of CPU. Yes. How do these function? Yeah, everybody was, see, ALU is going to get functioned by the type of things that you use, but when I say about control unit, it simply functions by your CPU. You know, they have lots of CPUs in the market, those are available. There are so many kinds of central processing units. For example, if you go for a computer shop, if you go for a computer shop, the only thing that you can just remember is you can see different types of CPUs over there. So when I say the different types of CPU, you have so many updated versions of CPU. When I say the updated versions of CPU, you have different designs of CPU and control systems of CPU. So all those are actually being controlled by the control unit. The control unit and its functions change by the CPUs. And the third point here, it handles all the processor control signals and directs the input and output flow. Yes, when I say about it, all that you just have to remember is it handles all the processor control signals. You know, from processor we have control signals which indirectly or directly are being directed by the input and output flow. Yes. So when I say this, if you can see the diagram here, we have inputs and output signals coming to the control unit. So let me retake you with the third point. It handles all the processor controls signals and directs the input and output flow. So when I say about this, it takes the processor, you know, you have something called as processor in the CPU. When I say about the processor in the CPU, the processor will take all the signals and directs the input and output flow. See, the information which is being gathered by the input devices, for example, you are typing something on your keyboard, the first thing that it happens to is the ALU. Once the ALU give the controls to the control unit, I mean it takes the controls and give it to the control unit, and the control unit will try to operate the controls from the processor, and it gives the again inputs and outputs to the ALU, so that ALU will give you the output. So this is again a vice versa game played by the CPU. Alright. So now let me take you with the last point in the slide, that is, it regulates the timing of the processor. For example, yes, depending upon your CPU, for example, you have gone to the market. Once you go to the market, you will have so many kinds of CPUs. You have less configuration, you have high configuration, you have medium configuration computers. So when you go for the last or the old version of CPU, yes, obviously your system will be slow, isn't it? So medium, a little bit fast, and the upgraded systems right now in the market are very fast. And why is that? Because of the CPUs and the control unit. It regulates the time, because until and unless it takes the entire information, it can't revert back the function. So to give back the function, it have to be very upgraded. The control unit have to be very upgraded to give the correct information in the correct time. So if you want the information to be given in a seconds of time, then you have to go with an upgraded system. All right. So this is what a control unit is basically used to control the functions inside the CPU. So this is what a control unit is. Now let me take you with the control unit initial diagram. Yes, the step 1, fetch instruction to the memory. Step 2, decode instruction into command. Step 3, execute the command, which has been happening through control unit. Step 4, store instruction in the memory. So I think now you people have the basic idea about what does the control unit do. It fetch the instructions from the memory, that is the main memory when we are giving an input, and ALU will decode instruction into command, where control unit is something which is controlling the command, executing the command in the system, and then the last is store instruction in memory, so that this is what exactly is the output. Now, this output is something that you have to remember, because we are getting this output through control unit. All right. So, now let me take you with the next slide. When I say this, a rectangular signal from quartz generation is the timing unit, and then it goes to next control state generator, and then control signal generation matrix. This is the chip diagram of the control unit, the work diagram, and then we have flags and variables getting inside the next control state generator, and then we have control signal generation matrix, which are called external signals, and we have OP code address field into instruction decoder. Yes, how do it decodes is always an question. In the previous diagram, if you can see here in the slide, we have execute command. So, when I say execute command, before that there is something called as decode instructions into command. So, I will tell you how is this decoding happening in the control unit. So, this is the basic diagram that you have to remember, how exactly control unit receives the code or a command from ALU. I want, if possible, everybody to have this basic diagram in your notebooks, because this will help you in understanding tomorrow to command or to instruct somebody about the CPU and its components, right. So, please go through the slide once again. You have timing unit, next control state generator, we have control signal generation matrix, and then which all receives from instruction decoder, that is through OP code or address field, that is simply called as instruction register. And for the timing unit, we have rectangular signal from the quartz generator. Now, before we go with the registers, I was talking about control unit, that is CU, and before that I was talking about ALU, all right, arithmetic logic unit. So, when I say about arithmetic logic unit, we have something called as the main command system, which gives inputs and outputs, but to give the inputs and outputs, control unit is helping ALU to decode and execute the command. And now, what do the third important thing in the CPU, that is registers, do? The registers are the most important thing that you have to remember, because yes, these are also the most important components of the CPU. Register is the temporary memory used by the CPU for temporarily storing data during execution of information. Instruction decoder, it is a device that interprets the instruction to be executed. Programmer counter, it holds the address of the next instruction to be executed. Instruction register, it holds the instruction being executed. Process status register, it holds processor bit about operations done by ALU. When I say about register, we have instruction decoder, programmer counter, instruction register, and process status register. If you can see the diagram, we have core, and then we have code cache, and then we have instruction decode and prefetch unit, and then we have branch predictor, we have integer ALU, and then we have registers, and then we have execution unit, and then we have FPU, which does the divisions, and then we have 32 bit buses, and then we have data cache, and then we have level 1 cache, and then we have bus interface, and then we do have 64-bit bus. All this information will go to the RAM. So this is what you just have to remember when I am talking about the registers. So when I say about the registers, these are a basic, a temporary memory. For example, when I say why are registers important, you know about the registers in our normal life, isn't it? The registers are just simply mean the temporary data. You will have the data for that particular moment. So yes, registers in the computer also refers the same. These are the temporary, see for example, yes, we are storing the memory in our hard drives and everything, but to function the computer also needs some space to calculate, isn't it? It's not just an on screen that things happen. So even computer requires a basic space, a required space to calculate the functions in the binary language, because matrix is an ocean. So when I say about the matrix have lot of calculations which happen in a second. When I say a lot of calculations, they have so many multiplications, subtractions, additions and divisions. All these functions that happen in the binary language will obviously calculate some space. So this space is actually being given by the registers in the CPU. So registers are so many types. If you can see in the diagram, we have so many kinds of registers. So all these registers are something which helps to process this function to the RAM, so that the RAM revert back with the information or the function. Now this is what you just have to remember when I talk about the registers. So let me go take you with the deep inside of registers. Where are actually registers playing the important role? Yes. So obviously everybody have what is CPU register. I'll tell you about it. So before accumulator, it stores the intermediate and final results of calculations. It's the main working area of the ALU. General purpose register, it can be used to store any temporary information during the execution of instruction, which I already have said you. Memory address register, which is very important, MAR, it holds the data that should be accessed. And then we have memory data registered, which is MDR, it holds the data that is transferred to and fro. And then we have address decoder, it interrupts the address in the MAR and selects the appropriate cell in the main memory to be accessed. All right. So now when I say about register, of course we have accumulator, general purpose register, and we have MAR and we have MDR. So now let me clearly tell you what does a register play a role in the computer. So when I say this, there is some information from ALU through the control unit given to the register, and this register will make sure it holds the data, calculates in this register, and then gives back this information to ROM or RAM, and then it gives back the information, takes back the information from registers, from the RAM and ROM put it in the register and then give it back to the ALU and the control unit. So this is the most important thing that you have to remember, because registers are something which are bifurcated as MAR. It holds the data that should be accessed. I mean, when I am giving a function, this function is being taken hold of the register. I mean, the register will take the information and do the mathematics job exactly in the register. The register will be capable of calculating the functions in the register and then give back to the ROM or RAM, so that it revert back the information getting calculated in the RAM and ROM, and then it will take back again with the help of MDR, and then it gives back to the ALU and the control unit. So remember all the time, register have two important things, that is MAR, and the full form of it is memory address register, and we have MDR, which I can say memory data register. All right. So these are the two important things which calculate something, I mean not something, the functions and the things that are important in the calculations, and these do the calculation job and give back the things to the control unit, which is controlling the entire functions into the CPU, and then it gives back to the ALU, that is arithmetic logical unit, and then you will find at the end the important information that you want. So registers are the most important things that you have to remember, because the calculation part especially and the data, you know, they have this temporary data where the calculations can happen. So registers are the most important things that you have to remember, because these play a very important role, because if these are not there, calculations will never happen, because the temporary data will be held by the register, right. So now let me take you with what is a CPU register. Yes, in the CPU register we have the most important things, those are accumulator, MAR, MDR, and address decoder. Address decoder, if you can see the slide once again, yes, we have, it interrupts the address in the MAR and selects the appropriate cell in the main memory to be accessed. What does this do? It interrupts the address. For example, when I say address decoder, I was talking about the decoding, isn't it? So when I say about the decoding, this will play the most important role in decoding the function. That is, it will take the main function that is being given through the ALU, it will take from mother, or you know, it will take from the memory mother, and then it tries to decode the address, and it calculates the information and give back the same information to the main function or to the main memory, so that at the end you can find the information gathered on the screen. So these are the most important things, those that play the initial role in functioning of your information and the calculations. So always remember, ALU is arithmetic logic unit, where of course if you can say, you know, it makes sure that it functions very important things in it. And then we have control unit, which actually controls all the information gathered and gives back into the CPU. And then we have registers, where it have a temporary data to calculate and give back to the memory unit, and it plays also a very important role in decoding. So these are the three main components of the CPU. And remember, when I say the brain, we have the three most important things in the CPU. Those are these: ALU, control unit, and registers. Without these three, nothing can happen in the calculations or giving the information back. So this is what we have learned today, that is CPU and its importance and the brief of the CPU. So I hope everybody will remember whatever I have taught you. If you have any doubts, obviously you can put those questions into the below mentioned things, right? So thank you so much for having this class, and please don't forget about the CPU. So I am Kranth, and have a very good evening. Thank you.